Hey everyone, and welcome to section 7.2 about adding and subtracting rational expressions. Yay! Um, so this is kind of a rough one for a lot of people. So let's walk through it. Remember that when we add or subtract fractions, we need to have the same denominator. Otherwise, if you think about fractions in terms of parts of a whole, if the pieces aren't the same size, then things are not measuring up the way they're supposed to, and so you really do need the denominators to be the same. Rational expressions are no exception to that. So here we have two sums of rational expressions. Let's go ahead and add and then simplify. Alright, so the first guy, we have the same denominator, so we really do just add the numerators together. We don't do anything with the denominator. Then we want to simplify, and so that means factor. See if we can reduce this expression at all. So by now you're starting to get a little bit better at factoring things, feeling a little bit more comfortable. So let's see, we want to factor the numerator. X plus 4 divides out. So I'm really just left with x plus 7. So that wasn't too bad. Let's kind of see how it goes for this next one. 4x squared. I want to draw your attention to what we're doing. We're subtracting. Okay, so we have to subtract the entirety of the fraction, which means we're going to have to take this negative sign and we're going to have to distribute it to each term in the polynomial. I have minus 3x squared minus x and plus 3 over this. And I want to simplify. Okay, so I have x squared plus 11x plus 11 all over x squared minus 3x plus 2. Let's see. I'm running out of room. So let me erase this stuff. There we go. So if I want to simplify this rational expression, I have to factor, like usual. Just so happens that these are pretty easy to factor, so it's not too bad. The x minus 1 factors divide out, and what do you know? Bob's your uncle. We end up with x minus 11 over x minus 2, which isn't so awful looking. All right, so we're going in baby steps of awfulness. Here's something that's slightly more awful, but not too bad. Slightly more awful because the denominators are not the same in this instance. They're opposite. But if you recall from the video on factoring, we can make a small change. If I factor out this negative 1, then I can switch the order of the denominator. And really, when you put a negative in a fraction, it doesn't really matter where it is. So I'm actually going to rewrite this to be just subtracting the whole fraction, which gives me m squared minus 6m minus 3m plus 2. Remember, I have to subtract the entire numerator. as kind of one thing. Of course, I want to distribute my negative sign to get m squared minus 6m minus 3m minus 2 all over m squared minus 1, which simplifies to m squared minus 9m minus 2. And I don't think we can factor that numerator, so let's leave this as is. Call it simplified. We got other expressions to look at, so. All right, so now we're starting to get into kind of dangerous territory. Okay, so really weird, I just said we're getting into dangerous territory, and then it started thundering outside. So I don't know what that means, but it means something. All right, so we want to add these two rational expressions together. I need a common denominator to be able to do that. So first of all, I'm going to factor the numerators and denominators completely. It'll make life a little bit easier, I promise. So m squared minus m minus 2, that factors as m minus 2, m plus 1, plus 3m plus 2. And then that one factors as plus 2, m plus 1. All right, so what do I need as a common denominator? Well, I see that I already have m plus 1. The first fraction does not have an m plus 2. So I'm going to multiply by m plus 2 over m plus 2. What about the second one? The second one does not have an m minus 2. So 1 times m plus 2 is m plus 2. M minus 2, m plus 2, m plus 1. Then for the second fraction, I have 3m plus 2 times m minus 2 over m minus 2 times m plus 2 times m plus 1. Great, so I think I have to actually FOIL now, huh? To successfully add. And now I can add the numerators. I gotta clean up a little bit. And I don't believe that that numerator factors anymore, so we'll leave it as is. Unless I've made a mistake somewhere, which is very possible. Next up to bat, we have 3x minus 1 minus 2 over 6 minus x. So let's start again by factoring. And what we're going to do is switch the order and switch that sign. All right, and now to get a common denominator, if I multiply the second rational expression by x plus 1 over x plus 1, I think that'll get me where I need to go. We end up with 5x plus 1 upstairs and x minus 6 times x plus 1 downstairs. All right, one more, last one. for this video, I promise. So again, start by factoring. It's pretty much a safe move whenever you're dealing with rational expressions, is to just factor everything completely. And let's see. So if we multiply the first fraction by y minus 1 over y minus 1, and the second fraction by y plus 1 over y plus 1, then I would get a common denominator. I would get y plus 1 times y minus 1. Now I'm going to distribute and simplify just to see if I can't reduce this expression anymore. And it looks like that's as far as I can simplify it, because if I wanted to factor the numerator, I'd want two numbers that multiply to give me 3, which there's 3 and 1. But it's positive, so they have to have the same sign. And then it wouldn't add up to 2y in the middle. So yeah, I think this is all set. Okay. Well, that about covers it for adding and subtracting rational expressions. I'm going to keep the pain train rolling. Next section is about simplifying complex rational expressions, which is fractions in fractions, or rather rational expressions in rational expressions. It's a lot of rational expressions. So, enjoy that.